welcome. We're going to have a look at levers with a focus particularly on mechanical advantage. Okay, there's two different kinds of mechanical advantage in levers. You have a mechanical advantage of speed and a mechanical advantage for strength. Now we're just going to first of all have a look at how you would calculate a mechanical advantage as far as numbers are concerned. So if you had this is the fulcrum and you had the effort and the load, okay, you always have a look at, so this is shorter, that's the effort arm, so the E arm, and this is here, this is the resistance arm. Sorry, I keep putting load, but you need to remember it's resistance. This is the R arm, resistance arm. Now you always have to calculate the mechanical advantage to give a number. It's always the effort arm okay, divided by the resistance arm. Okay, so generally if the effort arm is shorter, okay, then the resistance arm, okay, the figure is going to be below 1. Okay, so say for example that was 7 centimeters and that was 10, okay, then your effort arm would be 7 divided by 10 equals whatever that is, it's below 1. Okay, now if the effort arm was longer, okay, right, all the way up to here, then you'd probably say that was, say, twice the length of that. You would say it's 20 centimeters. Okay, that would definitely be above. So it'd be 20 divided by, that would be above 1. It'd be more like 2. Okay, so if it was more like 2, so if it was this, you would have a mechanical advantage for strength. So anything above 1 equals strength. Anything below 1 equals speed. Right? So all you have to remember is this, calculating. This will come in later, okay? But all you need to, that's the main thing you need to remember, is how you calculate the mechanical advantage. You might possibly get a question on that. All right, now I'm going to just clarify exactly what these are, okay? So I'll just do this again. Defining the effort arm and defining the resistance arm. I'm really hoping that now these are going to become more obvious, okay? So if that's the resistance, that's the effort. Now to figure out the effort arm, okay, these are key terms. Key terms. Effort arm, resistance arm, and then mechanical advantage. Okay, the effort arm is the distance between the middle of the fulcrum to the middle of the mass. So for example, in the you might have a load here, okay, that you're trying to lift. If it was like the end of your hand, for example, there's the fulcrum at the elbow, and the weight was the pen, okay, then the middle of the pen to the middle of the joint, the elbow joint, is the resistance arm. Okay, that would be that. Sorry, totally confusing. That would be there. Sorry, that would be the resistance arm. So the middle of there to the middle of the fulcrum would be the resistance arm. Now the effort arm, okay, which is the muscles making the effort, so that's the other side of the fulcrum, okay. It would be measured from the where the muscle is, okay, contracting, if we're talking about the body, when the muscle's contracting to the middle of the fulcrum, okay, and again, that would then be the effort arm. Okay? Effort arm, resistance arm. Okay? Now, if we're having a look at mechanical advantage, you need to remember, okay, that you get a mechanical advantage if your effort arm, if your effort arm is longer, okay, than your resistance arm, so resistance is there, effort is there, then you would gain the mechanical advantage of strength. So mechanical advantage for this situation here equals strength. Now, let me explain that. Let's think, for example, you have a situation where imagine you had this is a lever system you would use to sort of lift a rock, okay, a big heavy rock, okay. So this could be the same situation, and there's got a boulder there or a rock or whatever. That's the resistance, okay, the weight. That's the fulcrum, and then your effort is also going to be pulling down in this instance, okay. If you have a longer effort arm, it's going to be easier to move that rock, okay, because it has a mechanical advantage. If you only had a stick which was this long, which was a lot shorter, which was the same length, okay, as the resistance arm, okay, that wouldn't have a mechanical advantage. So that lever system wouldn't have an advantage. You need to lengthen the effort arm in order to gain more strength. Okay. Now, an example in the body that you see of the effort arm being longer than the resistance arm, hopefully you should all know, is in the ankle. Okay. So remember, I'll draw the ankle. So that's the leg. You got the foot. You got the fulcrum is where. Imagine if you're going up onto your tiptoes. This is your calf muscle. You have the fulcrum is the balls of your feet, okay. Your body weight is in the middle, okay, and the force is from the calf, so it's on that side. So effectively, you've got this going on. Effectively, you've got the fulcrum there, the resistance there, and the effort there. That means, okay, that your resistance arm is shorter than the effort arm. There's your resistance arm from the middle of the fulcrum to the middle of the resistance, and there's your effort arm is that. Okay, so it's the same as this. The effort arm is longer than the resistance arm, meaning that in a class 2 lever system, you have a mechanical advantage of strength. I'll do that again. Class 2 lever system is resistance, effort. Okay, it happens in the ankle, class 2. You have a mechanical, let's call it mech, equals strength. Why? Because the effort arm is longer than the resistance arm. Okay, so that's for strength. Hopefully that's easy enough to understand. If you want a mechanical advantage to give you speed, you're looking at, again, let's think of this. You want, for speed, you want the resistance arm, let's do it the other way around so we keep it all the same. You want the resistance arm a lot longer than the effort arm. Okay, that's going to give you the mechanical advantage speed. Why? Okay. An example in the body is, speed. An example in the body where you'll find this is your class 3. So most of your levers in your body. Okay, we're designed for speed. Okay, so the fact that you've got such a long resistance arm, okay, happening here between the elbow joint and the resistance, so moving your arm, okay, means that your effort arm is tiny. It's only about there. It's from the fulcrum to where the muscle is there. The resistance arm's a lot longer. So and that's the same for our legs. Our limbs are made. We're made to move with speed and to have the mechanical advantage in our levers to give us speed more so than strength. Okay. Why does it give us speed? Okay. I've got a video that you're going to be watching after this that's going to show you an example of how it works actually in a small experiment. But just imagine, okay, that your effort is there, your the fulcrum is there, and your resistance is there. Now, if that moves from there, okay, let's say to there, so you've got that amount of flexion going on. Let's imagine this is the arm, the bicep. Okay, so you've got, that's the distance it moves. So say, for example, that's about 45 degrees. Let's say in centimeters wise, so distance wise, it's part of the circumference of a big circle. That would be, say, for example, let's say 20 centimeters. Now, you've used the same effort, the same force, all right, to move that. Compared to if you had the resistance here, okay, so a smaller resistance arm, and you applied the same force, okay, same force, okay, you would then have this distance. So say, for example, that didn't even exist, that part of the resistance arm. Say, for example, the weight was there, and that was your resistance arm. Now, what's happened is you got the same effort, the resistance has moved the same, it's moved the same angle, but what's happened is, so in this same period of time that's taken to get from there to there, that has gone from there to there. Okay, that's happened in the same period of time. Now, this, let's say this, so but that's traveled 20 centimeters, and that's traveled about 7 centimeters. So if that has traveled from there to there over 20 centimeters, okay, in the same period of time as this has traveled 7 centimeters, then that means this part here, that is traveling at speed. Okay, compared to this. All right, that is traveling faster than that. Okay. Now, in the experiment that I'll show you on the next video, you will see an example of that in action. It's very difficult to understand that right now, so I should have maybe sort of used 2 different diagrams for this. So you've got that diagram there, and then you would have a separate one where so again, you've got that, and there's resistance. So if you had those 2 lever systems going on, you would get a lot more speed from that than you would from that. The reason why is because with the same effort, that has traveled a far greater distance in the same time. Okay? Right, keep up with me. So that's if you have a resistance arm which is longer than the effort arm, your mechanical advantage is speed. Okay? Right, finally, examples. So for speed, mechanical advantage, rowing boat, you have the dudes here, pulls on the oar going that way. So he's just pulled it from there to there, and the oar is in the water there. Now what you've got here is the fulcrum. The effort is him pulling, and then you've got the resistance, the water, and actually the length of the oar. Okay, so when he pulls, when he creates the effort and pulls there, you've got a short effort arm and a long resistance arm. That should mean mechanical advantage equals speed. So but that paddle is going to be traveling at great speed because the resistance, because when he pulls onto it now, okay, effectively what's going to happen now is that's going to go from there to there in a very quick period of time. So he's got a small movement that's happened here, but a large movement that's happened here. It's happened in the same period of time. It's traveled a greater distance. It's giving you speed. Okay, so that's an example in sport. Another example in sport could be golf. You want to hit the ball a great distance. Okay, you want to hit the ball with a far distance. Okay, that's why the clubs, the drivers, okay, are so long compared to, say for example, the short distance clubs, which are shorter. They give you more control. This gives you more speed. Okay, because this is going to be moving. The club head is going to be moving. Okay, it's going to be covering the same. It's going to be covering more distance in the same period of time. So it's going to give, by the time that the club head makes contact with the ball, okay, it's going at a great speed. There's a mechanical advantage here. Okay, again, the fulcrum is there, the effort is there, and the resistance is here. So you've got a great resistance arm. Okay, the greater the resistance arm, the more the mechanical advantage of speed. Right. Hopefully that helps. You've got the use of this video, the other video, and then also you've got the PowerPoints to help you with it. All right.